All right, as I said, I wanted to also explain very briefly how a transformer works. Okay, and I mentioned this in my first video, which was that the transformer works with an alternating current. Okay, it does not work with DC. You cannot have a transformer which is working with a DC signal. Okay, it must work with alternating currents. Now, the reason for this is because on our primary coil, we have an alternating current, and that produces an alternating magnetic field. We know from our right-hand rule that as the current changes its direction, the field will also change its direction. So we have an alternating current which produces a changing magnetic field, and that is starting, if you like, in our primary coil. Okay. Well, if the field in the primary coil changes, then the field in the core must also change. Remember, we said in the first video this was a soft iron core. It gains and loses that magnetism instantly. Okay, we would not use steel for this purpose because steel would keep the magnetism and it wouldn't allow that rapid change that we're looking for. Now, hopefully you can see where we're going here. Whatever changes in the primary coil changes in the core and therefore must also change inside the secondary coil. And here what we're doing is inducing an EMF. The result here is that we induce an alternating current in the secondary coil. Okay, now the more loops that we have on there in that secondary coil, the more EMFs. Essentially what happens is each little loop gets one EMF, and we add up the EMFs to make a greater or a lower EMF, depending on whether this is a step up or a step down transformer. So this is really the simple bit. Now, the reason I'm putting this in is a student misconception, which often happens. We think that maybe the electricity is passing directly from coil to coil. Actually, that's not the case. We actually have simply that magnetic field carrying our change, and that is really the key to this transformer. Okay, now it's very unlikely that you get asked a question about this working in a GCSE level paper. However, you may get asked about why the goodness we do it. Okay, so I just want to take 30 seconds to talk about that. All right, a key point during this is that we assume in transformers that energy is conserved. Okay, in other words, all of the energy in my primary coil becomes energy in my secondary coil. Now, you may have remembered that this is to do with energy and therefore to do with power. That basically means that power is conserved, and power is the product of current and voltage. What this means that if the potential increases, so if we're stepping up, then current also decreases. Okay, so in this case of a step up transformer, what we're doing is stepping down the current, and sometimes we see this expressed in this version. Now, I tend to keep this out because I find it gets very confusing for students. Okay, we have our turns ratio Vs over Vp equal to Ns over Mp equal to Ip over Is. So you can see here, if V is going up, I is going down. Why would we do that? Well, we would step up our voltage so that current becomes lower. And as a result, what that happens then is we reduce the power losses. And the way that we can look at that is through our equation P equal to I squared R. Okay, as I gets lower, P also gets lower, and so therefore we lose less energy to heating. Now, this is a tiny, tiny point that just comes up in the GCSE syllabus. You're not expected to do any calculations about this, but I thought it was one that, especially for those of you who are looking for an A star or A level students, really want to start thinking about this. This is exactly why we step up that voltage to step down the current in order to reduce our power losses. As ever, if you have any questions, please feel free to ask them.